Hi there, my name's Kate Freeman. I'm going to be talking about the global market and technology trends that we've seen in offshore wind and what this means for Korea. So the first thing, who am I and why am I talking with you? So I'm from BVG Associates, which is a consultancy in offshore wind. I'm based in the UK. And my main theme is in economics. But the whole consultancy covers strategy, economics, and technology. We were founded in 2006 at the same time, really, as the offshore wind industry. So we've been growing with the industry and have 50 landmark publications to our name. We've been involved in industry building for offshore wind throughout the past 15 years. We've done the first roadmap and supply chain assessment in the UK. We've led on ports. You may know us from our guide to an offshore wind farm, the first of which we did in 2010. But we recently updated in 2019, and that can be found at guidetoanoffshorewindfarm.com. We also led cost reduction pathways. We've thought about R&D, about innovation. We've also looked at local content methodology, in fact, authoring that. And not only have we been looking at offshore wind from a UK and Europe position, we've also been involved in the US, working in the East Coast since 2014. We've looked at Europe as a whole, including authoring the 2050 vision for 450 gigawatts of offshore wind. In Asia, we led the cost reduction study in Japan. We authored the World Bank's first offshore wind country roadmap for Vietnam, and we're currently working on those for Azerbaijan and Philippines. And then globally, we authored the ORIAC 2050 vision for 1,400 gigawatts of offshore wind by that date. And we were co-authors for the World Bank's Key Factors for Successful Development in Emerging Markets report. So we've done lots of industry building, but we don't just do those kinds of big reports. We also work for private clients, whether those are governments, whether those are operators of wind farms. And really, whenever our clients want to do new things, that's when we get involved. We've done lots of thinking through new problems and getting the balance right when we're talking about tough problems. How precise do we need to be? How general? And in particular, we're involved where strategy, economics, and technology overlap. There are plenty of consultancies that do each of those. We tend to get involved where you join them together. And in Korea, we delivered multiple projects, often working with Blue Wind Engineering. So thanks, Joan. Specific things that we've been doing in Korea, we've been working through a government industry deal. We've helped Korean suppliers to enter and grow the offshore wind market. And then we've helped project developers assess local economic benefit, supply chain, and project site finding. What I will say is I'm not from a company that does standard project development. We don't do EIAs, site surveys, detailed design, nothing like that. It's that strategy, economics, technology piece. So that's where I come from. Hopefully that means that I've got that overview to think about those global trends, because that's what we're going to be doing. So let's take a couple of minutes and think about what those key global trends are and how they've changed over the last year. So if we think about all the parts of offshore wind, what's been going more slowly than expected, about as expected, and what's been going more quickly than expected. So US offshore wind, a little bit more slow. Impact of Internet of Things, artificial intelligence, big data, those are maybe a bit more slow than expected. Similarly, carbon taxes and pricing, and also energy system policy, mechanisms that encourage huge scale investment and different technologies coming together. All of those maybe a little bit more slow than we might expect. But there's a group of things which have been going at the pace that you might expect for offshore wind, and it's offshore wind, so at quite a fast pace. So the industry is maturing globally. It's an industry, not a little sector. It's a whole industry. The cost of offshore wind is reaching toward grid parity, and there's a kind of beyond subsidy move to merchant risk at the sort of pace you'd expect. Also, turbine supply changes. GE has been growing its market share, and Vestas has de-merged, and it's sort of widening its scope. Similarly, the turbines are getting bigger, both onshore and offshore, at that quite rapid rate that you would expect for wind energy. Some things have been going even faster than you might have expected a year ago. In particular, interest in emerging markets, including governments both wanting local supply chain and offshore wind in quickly, and also from project developers being interested in going into those emerging markets. Similarly, oil and gas players getting into offshore wind, that's been coming on more quickly than one might have thought a year ago. And floating offshore wind going along with that, that being something that those oil and gas players are particularly interested in. Finally, another item that's moving faster than we might have thought a year ago is hydrogen, power to gas integration. It's not a joined up picture maybe, but lots of individual projects thinking about that piece. So with those technology global market trends, what does that mean for emerging markets? What does that result? First thing, if you can have clear policy drivers, that really helps. There are different things that a new market might focus on: low cost electricity, local jobs and economic benefit, security of energy supply, and environmental sustainability. All of those are reasons that a new market might get interested in offshore wind. Often there's a tension between A and B, between low cost and local jobs and economic benefit. But as long as it's clear what the drivers are, people can get through that. Whichever of the drivers are important, visibility and confidence about the large volume over time helps with all of those drivers. So it's clarity on policy drivers. Other key success factors: strong frameworks, making sure that seabed leases, permitting, power purchase, grid and financing are all really clear, very strong policy settings. That's really helpful. Along with those, making sure that the projects are bankable, that the resources are being used efficiently, and that people have confidence in that market. That's going to help push forward. Good communication and coexistence between government enabled and private sector, very helpful, but keeping the competition so that you can drive down cost. Those all help, those provide you that strong framework in which an industry can grow. Third key factor for success: consistent delivery. So if you want to build volume, you need institutions that have the resource, you need proactive management, and you need industry and government to be talking really well. And finally, you're going to need a competitive supply chain with the right amount of local content. So you need all of those pieces delivering consistently together to grow that industry. So key success factors: clarity on policy, strong frameworks, consistent delivery. So where's the market at? So what we can see on this slide here is we can see the growth in the market in gigawatts on the left-hand side, and the growth in the market in currency, in this case sterling, on the right-hand side. So we can see that the market's moving from being a regional European market to being much more global. Within that market, there are three key regions: Europe maintaining one of those regions, Asia coming in, and then Americas being the third region. On the right-hand side, we can see what that translates into in terms of expenditure. By the end of this decade, we're expecting to spend over £95 billion, which is going to be over $100 billion. So this is a serious market in the world. Well, that set us up overall, showing what's going on in the offshore wind market, what that size and scale is. But if we're thinking about offshore wind in Korea, we're going to need to have some thoughts about floating offshore wind. So first thing to cover, what is this floating offshore wind? What are the technologies? What's actually driving it? Well, first thing is there are a number of different ways that the turbines can be held up. So here we can see a semi-sub or barge, spar buoy, and a tension leg platform. That's three different fundamental foundations which float and which can hold a turbine. Well, why do we need three? At the moment, there's no particular prospects that we're going to harmonise on one, but why might that be? Well, if we think about the key drivers, that's going to show why one might be better or worse than another for a given situation. First, lifetime cost. We want something quite cheap, but we want something that's going to work. How's it going to work? Static stability. That means it's going to hold the turbine. Dynamic response. That means it's going to hold the turbine even when the wind and the waves and the current are moving around it. We want to make sure that none of those forces cause any kind of disruption or failure. 4, manufacturing standardization. We want something that's easy and repeatable to manufacture. If we think about cost, static, dynamic stability, and manufacturing standardization, different technologies are going to be better or worse. So something with a lot of material is probably going to be quite stable, but potentially expensive. Something with less material might be less stable, but potentially cheaper. If you can make a very standard kind of structure, that's going to be helpful. But if making something more complicated enables you to be more stable or cheaper in some other way, because you can use materials differently, maybe that's going to win out. So that's thinking about the different sort of shape of the structure. The other things to bear in mind are designing for something right now is all very well, but is it going to scale well with increasing turbine size or with different rotor size of the turbine? If you can design something that's great, but by the time you get to a 20 megawatt turbine, for example, the cost, standardization, and stability responses are not so good, then that's probably not going to be the thing to go for. Sixth on that list there is the ground and metocean conditions. If if you're looking somewhere where the ground conditions are sort of bedrock on the surface, bedrock on the seabed, then that's going to have different requirements for anchoring to something where there's lots of layers of sand and mud. That's going to mean that something that anchors into rock very strongly is going to do better than something where you're anchoring into that surface. So those are all different considerations, different drivers for why one or other technology type might do well. For all of them, there are some challenges. Efficient manufacturing and installation, the logistics of this aren't solved yet. For commercial scale projects, we need a lot of land. It takes a long time, it takes up space. How is that going to work for a long-term project? How do you replace large components? Do you tow to shore? Do you do something at sea? Both of those have potential downsides. And then third, with all of those pieces, how do you make sure that you reduce costs, have a nice optimal design? And then fourth, once you've solved all those problems, how do you make sure that clients and the supply chain really believe in you? So that's what you've got to get to. You've got to solve all of those challenges. But people are getting there. On this slide, we can see the floating offshore wind market in gigawatts on the left-hand side and in pounds on the right-hand side. If we think about how that looks in comparison to the whole of offshore wind, the floating portion of it is certainly more modest through the 2030s, but by the end of the decade, we're looking at over £10 billion per year expenditure. So that's a pretty reasonable market, one that various people are getting interested in. But how do you get there? So this is taking that same piece that we were looking at on the previous slide and thinking about what technologies are actually going into this. So to begin with, we've got very small projects, prototypes, demonstrators. As we go through the late 2020s, we're into early commercial projects. So these are under 500 megawatts, but they're doing all of those logistics solving pieces. And then from the first half of the 2030s, we're into fully commercial projects. It's a similar journey to other new large-scale technologies, that prototype, demonstrator, early commercial, full. But that's how it sort of steps up through floating offshore wind. But how do we get there, given that the expectation is that floating offshore wind is going to be a bit more expensive for much of the next decade? We've got the challenge that there's a difference between the subsidy-free offshore wind and the premium floating offshore wind. We've also got a challenge with uncertainty. Floating offshore wind still has quite a lot of uncertainty about its levelized cost of energy. I've put together two groups here that we've got technical uncertainty and commercial uncertainty. In the technical uncertainty, we're looking at manufacturing and logistics, making sure that everyone knows how to do those safely and cheaply. And then in the commercial piece, we've got uncertainty around market volume. How quickly are people going to want to do things? About supply chain confidence or investment, who is going to want to do this? And also about how these projects will be seen by financiers. Combining the uncertainties from the previous slide, we see a pattern of LCOE which looks like this. So for the most part, the floating offshore wind is a little bit more expensive than the bottom fixed, but we can see in certain sites that the floating offshore wind is looking pretty good. And as we get towards the end of the 2020s and into the 2030s, that's increasingly the case in lots of sites. And that's going to be a key piece for Korea. How far into that good quality floating offshore wind site are you looking? Which ones are going to come out well? That was our tour through floating offshore wind. Other pieces which are going to be important for Korea is about the technology. It's just got really big. We can see here the nacelles that are being installed on projects from 2023. You can see it in comparison to some people on the left-hand side and in comparison to a railway boxcar on the right-hand side. These structures are really large. They're also very massive, so they need to be supported very carefully. The blades have got longer and longer and longer. You can see there two Dreamliners, the wingspan of 3.6 of them. That's the length of the GE Haliade rotor blade. These are very, very large pieces of equipment. Similarly, the foundations have got extremely large. Here's a monopile which is 8 meters in diameter and 93 meters in length. You can see the scale of it with the people in the picture there. And here we've got the Haliade as though it's being installed. You can see in comparison for scale the Samsung Tower Palace and the Lotte World Tower. These are big pieces of equipment. So what does this all mean for Korea? We've looked at global trends in offshore wind. We've looked at the market size. We've looked at floating specific pieces which are important in Korea, and then we've looked at the scale of these structures. Well, there are huge opportunities. For both government and industry, a really collaborative way forward is a very positive thing. Clear market policies, strong frameworks, good communication, and taking the benefit of the international relationships that Korea has, all of those are going to be very useful in making sure that offshore wind thrives in Korea. Let's think some specifics. For government, getting volume of offshore wind at the right cost of energy is key for any government. There are ways that Korea can collaborate with experienced countries. There are ways that it can involve industry players with experience. It also needs to think about turbines. What does this mean for domestic supply when we're on turbines larger than 12 megawatts for a lot of the upcoming projects? Having a new organisation that does one-stop permitting, that would be really very useful to get projects flowing through. And making sure that government supports open and competitive supply chain that can export regionally. Korea's got fantastic industry that ought to be able to compete with its neighbours in the world. So making sure that it's got what it needs in place, that's going to be really helpful. In order to have projects come through to market, having a bankable offtake and revenue framework is going to be really important. Any time that there's uncertainty in what that revenue is going to be, that makes projects very hard to finance. And finally, specifics for government, making sure that the transmission network is planned and ready, that's going to be a key piece to unlock offshore wind. What does this mean for industry in Korea? Well, in many areas, the market opportunity and the competition is regional or even global. So learning from other markets, considering how to collaborate internationally, and playing to strengths, those are going to be really useful. The Korean industry can have Korean customers, but also global customers. So it's not just about Korean industry building Korean offshore wind, it's about global industry building offshore wind, some of which is in Korea and some of which is built elsewhere. The other thing to remember for industry, the technology keeps getting larger. So as it's so important for cost reduction, you need to plan investments with that growth in mind. There's space for new ideas. There's lots of opportunity here, and Korea could be great at that. Final piece for industry, there'll need to be new vessels, new foundation manufacturing, all sorts of other pieces to get this done. So planning with that in mind is going to be a vital piece for industry doing well. Okay, well, thank you very much for your time. I've been Kate Freeman from BVG Associates, and if you do have any questions or comments, the email address is there, and I'm sure we'd be happy to talk to you. Thank you very much.